Welcome to clickmyproject.com. Our project title is Clustering Sentence Level Text Using a Novel Fuzzy Iteration Clustering Algorithm. In comparison with hot clustering algorithm, in which a pattern belongs to a single cluster, fuzzy clustering algorithm allows a pattern to belong to all clusters with differing degrees of memberships. It's an important in domains such as sentence clustering, since a sentence is likely to be related more than one theme or topic present within a document or a set of documents. However, because most sentence similarity measures do not represent sentences in a common metric space, conventional fuzzy clustering approaches based on prototypes or mixtures of Gaussians are generally not applicable to sentence clustering. In our proposed paper, presents a novel fuzzy clustering algorithm that operates on relational input data, that is, data in the form of a square matrix of pairwise similarities between data objects. Our algorithm uses a graph representation of the data and operates in an expectation maximization framework in which they demonstrate that the algorithm is capable of identifying overlapping clusters of semantically related sentences, and that is therefore of potential use of a variety of text mining tasks. We also include results of applying the algorithm in benchmark datasets in several other domains. By clustering the sentences those documents, we would intuitively expect at least one of the clusters to be closely related to the concepts described by the query terms. However, other clusters may contain information pertaining to the query in some way, hitherto unknown as, and in such a case, we would have unsuccessfully mined new informations. Clustering text at the document level is well established in the information retrieval literature, where documents are typically represented as a data points in a high-dimensional vector space, in which each dimension corresponds to a unique keyword, leading to a rectangular representation in which rows represent documents and columns represent attributes of those documents, values of the keywords. Since data points lie in a metric space, we can readily apply prototype-based algorithms such as k-means, isodata, fuzzy c-means, etc., and the closely related mixture model approach, all of which represents cluster in terms of parameters such as means and covariance, and therefore assume a common metric input space. It's our data flow there. First of all, we are going to loading the dataset. Our dataset contains information about faculties, students, project, and etc. Then we are going to make the cluster by the user given choice. Then finally we are going to find the similarity measures for each and every document. Then we are going to compare the similarities of first document to the second document and also first document to the third document. So we are going to find the similarities and compare the similarities simultaneously. So finally we are going to display the files which document could have the less similarity values, and we are going to find the deviations and sum of the values. So by comparing these deviations and the similarities, which file could be reduced or which file could have the minimum amount of similarities, that file could be displayed. Let we see the demo of our project. Choose homepage.java and run file. It's our homepage. Proceed to the next frame. Then choose the dataset that we are process in our project. Which is named as diset.txt. And click view. These are all the data that is present in our project, and these are all the attributes that are present in our dataset. So we are going to proceed to the next frame. In this frame we are going to select the clusters by make use of these attributes. In handicap.infants we are get the values. These are the values that are present under the attributes handicap infants. These are the total values that are present in the data sets. That are non-handicap infants information could be displayed here. At the same time, handicap infants could be displayed here. So we are going to display each and every values corresponding to the attributes. For our adoption project, these are the values that are present under the attribute, and these are whole values, and these number of non-adoption budget papers that are presented under the dataset.txt. This adoption budget could be information could be displayed here. Then also physical free. These are all the informations. These are total values. These are the non-physical citizens that are present under the dataset.txt, and also physical fee-free citizens are present under the txt. So then proceed to the next frame. We are going to select a cluster or make a cluster and form as a sentences. So choose anyone, Republican or Democratic. If Republican, we are going to give if the handicapped infant is to be yes or no, and also and the given Republican should be belongs to a water project or not. Then we are going to display Republican should be belongs to a religious group or not. Then we are going to make a cluster and intern. We are going to make as a sentences, and it is also make as a cluster. So we are going to create a next cluster. On the same procedure, we are going to click any one of them. Then a Democrat belongs to a handicapped infants or not, and a Democrat belongs to water project or not, or at the same time a Democrat is belongs to religious or not. Then we are going to make cluster. The SNS could be displayed here. So we are going to display both every cluster A and cluster B. These are the values are present under the cluster B. Then we are going to find the similarity measures for each and every document by comparing document D1 and D2, and also comparing document D1 and D3. At the same time comparing the document D2 and D3. These are the similarity values by comparing the documents D1 and D2. These are the similarity values by comparing the documents D1 and D3, and these values are similarity values compared with D2 and D3. Then we are going to apply the fuzzy approach and fuzzy algorithm in this frame. We are going to sum the each and every sum values in a document D1 and D2 and D3. Then we are going to find this deviation values for D1 and D2, and also for D2 and D3, and also for D2 and D3. Finally, which among these three values, which one among the which has similar or similarity measures which less than other, that the file could be displayed. It's our final output. Thank you.